Thank you, Nigel, and thank you to all the speakers for keeping so well to time. It means we have a full half an hour for our panel session. So if I could invite Dave, Steve, Theo and Deepak to come up and take the red chairs, and we're scheduled to talk until about 10 to 5. So most of you have seen how this worked this morning. I'll kick off with a question to warm everyone up. Then I'm hoping that you all have lots of questions. We also have the possibility of some online questions in case you don't have enough to keep us going. So, gentlemen, the idea of connected machines and connected cities and smart cities is far from a new one. I can think back at least 15 years to people who've predicted it. Why hasn't it happened to date, and why might it happen now? Who wants to go first?
So I'll take a stab. I think there's two reasons. One is, of course, Moore's law is enabling technology to connect all these devices. It's now at a price point where it's affordable, and it's at a size where it's achievable and realistic. We also are developing standards that allow all these things to interconnect. So the great thing about standards is there's so many of them, and that's quite true with communications. And they're all converging now onto an IP backbone. So previously, your car could not talk to your house, could not talk to your phone. That's no longer the case. They can all talk to one another because of common languages that they speak. So I would say, in large part, Moore's law and standardization of communication.
I think I'd agree with that. I think, finally we have very powerful platforms all in our hands. And for urban, this development to happen, it needs to be available to everybody. And this has been a big catalyst. But also, I think people are seeing rise in urban population as a huge opportunity as well as a challenge. So now money is going behind it. So that's creating some of the catalysts. I'm involved in some projects, completely driverless train systems, where they want to know the demand of people using these trains before, they know by the intentions and the patterns and the way they interact with them. So they'll know when they get there, they'll need this train to go here, and the technology has made it possible today for that to happen.
Steve?
Of course, there's a technology component to what's happening, and I think the vast amounts of money that's been spent in research has caused the convergence, both in networking technologies and standards, in new methods of developing software, which allows us to innovate much more quickly on the hardware. There's a range of technology things, but I think it's overly simplistic to say it's just the tech. I think the absolute requirement for the growing economies, the developing economies in the world, is to drive greater efficiency so that they can turn greater economic output, so they can increase social development in their countries. Otherwise, we see a world even more socially disabled. So I think there's a very significant push as we move to meet a greater quality of life for everybody. And that's driven by citizens as much as it is by governments and politicians. It's driven by all of us. I think that's the principal driver to empower people to be able to be socially mobile, to be employed, to be able to participate, to be able to compete, and not to be connected and not to have the infrastructure to do it makes it physically impossible for those nations to be successful in a global environment. So I think it's economic as much as it is technology convergence.
Thea, any thoughts from you?
I think global standards is one of the key areas here of why the time is right now, whereas in the past it might have failed. But in addition to that, I think that just the sheer quantities of data that machine-to-machine throws out, we're only now capable of crunching and analysing and making use of that level of data. I think that's the key change.
Yeah. So an interesting mix of technology making things possible and societal changes making things necessary coming together to create something to finally happen. Yeah, I buy that. Okay, we have a question right at the back. If you could let us know who you are and where you're from, that's always very helpful. Thank you.
My name's Graham Gordon from a company called IFB. Questions around big data, which has been bandied around now for about 4 years by IBM and Gartner and everybody else. And 800% growth in data in the next 5 years and all these other things. But given the human nature factor in big data, how much do you think of that is scaremongering? That we've always hoarded things as a society and as a culture, but we burn it or bin it or we recycle it or we shred it. And the same thing's going to happen with data. We're only going to consume and retain as much as we need. There's a lot of pressure on the technologists, the Ciscos and the IBMs and the HPs, to actually develop compliance policies that protect our history. It no longer now sits with the individual to protect their data. There needs to be a set of standards that are drawn up by the technology companies who are shirking it to a certain degree to actually, when you're no longer a client, we will get rid of it. And offshoring data is that problem there. So how much of that do you see that big data is a way to sell more tin?
My experience of hoarding things based on our kitchen cupboards is we always keep slightly more than the capacity we've got. But over to the panel. Any thoughts on big data? Theo and then Steve. Yeah.
I think big data is coming through. I think there's huge, just the amount of data that is being churned out from social media and what you can do with that. So we've partnered with Jive, Adobe and Salesforce, for instance, and do something called Applied Customer Insight. So that's looking at all these different data sources that you can imagine and then starting to understand your customer more. So if I'm in an airport, for instance, the fact that I know that somebody's an impaired passenger who's got special needs, need to meet them with a buggy, for instance. The fact that I know because of automatic number plate recognition that they've actually just come in, they've given me that data, and I've merged that all together. I know where their flight is and things like that. I can get that buggy to them. So I can actually give a better customer service through that. So I think you are right. Privacy is a big issue, and we need to be cognizant of that. But I think the benefits are on the other side of how we then start using this. It's not about just crunching large numbers and selling boxes of tin. It's actually what you do with it. And I think that's on all of us in the whole of the industry sector to start thinking about how we can make more use of that.
Steve, did you have some thoughts?
I don't think it's a fad. I think it's out of the box and we'll never get it back. It creates some challenges. We've got a spiraling number of devices. At the moment, we're looking at, let's say, 1 trillion devices in 30 years. We've not even got down to a nano level of communication yet in gathering data. We're still at silicon. So I think, first, we're not even looking at our physiology in an intimate way yet. We're not looking at the broader set of physics that starts to play out in the processing of that data that expands the data. We look at just one simple form of data today, video. And if we had capacity, and now we have a number of devices around the world with a camera on it, you see this huge peak in newer, more complex, richer forms of data growing at ever-increasing rates. We do have a significant challenge. I don't think we yet can spatially process data in the way that we need to, with all of the effects on it. And the second issue is one of sort of archiving. Just a little while ago, this week, they discovered real proof that man had evolved the use of tools 20,000 years ahead of when we did. And we found some things in a hole and some paintings. And yet I can't even go back 30 years in an application and open a display-write X format in a piece of data that I want to be able to go get. And I'm in a small period of time. And so when we look at this next 100 years, the rate of morbidity in applications to access source data and the diversity of that data becomes a huge problem the way we think about the archaeology of our current time and how we learn from the data. And the final bit is sometimes the anomaly is so elusive you have to keep an immense data set to go back and reconstruct. You can collapse data, you can compress data, but ultimately you have to start looking at a much broader set of features, anomalies and elements to be actually find sort of the trail of how something developed. So I think we're on a path to mega computing and mega storage, and the storage devices are moving in completely the opposite direction in terms of cost and in terms of size.
Yeah, I think you're right. I think we're just at the thin end of the wedge. If you look at the way data is used right now, it's pretty predictive. But if you look at the potential of what's possible in the networks that we're talking about, You know, I mean, if you look at the way the whole genome project was conceived, right, in terms of the way it was divided across the globe, the internet was used to be able to, you know, divide and conquer. You know, I think we're going to be using a lot more data. I think it's a big challenge. And, you know, I think everybody's trying to innovate ways to store more cheaply. But I think in one of the lectures earlier on, I said most of everything we're going to discover is going to happen going forward, and that's going to need a lot of data.
Yeah, just to add a little bit to that. So we store 92% of everything we come across. Every email you get, every PowerPoint you get, every photo you take, you store 92% of it. We're seeing data get fatter. So we're seeing, for example, medical scans. You know, an MRI scan a few years ago, a few megabytes in size, now multi-terabyte in size. We're seeing fatter video, 4K by 2K displays, super high definition displays. We're seeing new types of devices, flexible displays, flexible OLED displays, tablets, phones. You know, the devices themselves are creating an insatiable demand to create and consume data. So data is going way, way, way up. By 2016, 90% of all data will be video. That poses a bit of a challenge for us. We do not have the tools or technology today to process video. I'll give you an example. Any one of us could go watch a movie, watch a film for 2 hours, and then someone could say to us, well, tell me about that movie. We have the pattern matching capability to sort of summarize that video, even if there are no words, right? The technology today is limited by the text that it can parse and index and sort. What if you had a video stream that had no text? How do you extract meaning from that? So one of the things that I see is we're sequestering a lot of knowledge, intelligence in 90% of all the rich data that we're creating that we don't yet have the tools to pull out. I think once we can start doing that, and we're making steps. You know, YouTube, for example, is starting to do closed caption and translation and things like that. We're making steps in that direction. But once we can harness that and unsequester the meaning behind rich data, I think it's very powerful. And the last comment I'll make is one of the really interesting things that I see about data that not a lot of people talk about. They talk about data analytics. What I think is interesting is about prediction. So what if you could predict fluctuations in your supply chain? What if you could predict fluctuations in customer sentiment, things like that? You can now take Twitter, that corpus of data, you can mine it, and you can start to predict the sentiment of the country. You know, who's going to win an election? What's the stock market, fluctuation going to look like? That, I think, is very promising. As we create more and more data, as we're able to harness the data and extract meaning from it, being able to predict the future puts me out of a job, which is a good place to be.
Thank you. Any more questions from the audience? We'll take one from over there. Thank you.
Sean Redmond, CEO of Coveritas. We're a software development tech tool company, UK-based. My question is about software quality. Everything we've heard about this afternoon is controlled by software, vastly complex software to control the protocols of these networks. I was interested this morning that LOCOG locked down all innovation that they were using for the games in 2010, not deploying anything new, anything innovated from that point on in terms of technology delivered. When you look at Bluetooth, which a number of you guys have been involved with in different companies, 10 years on, it's still riddled with bugs. 8 out of 10 products tested don't meet the Bluetooth standard. So my question to you is, how do you see the approach to software quality with the Internet of Things, machine to machine, where there's no user interaction to say, oh, we've got a problem, there's a bug, let's go fix it. It's a machine talking to a machine.
Very interesting question.
I'll answer it from a Bluetooth perspective as a guy who comes from a Bluetooth company. I kind of feel sorry for Bluetooth because it was here a long time before the applications we use it for. It was never kind of designed to do the kind of things we do with it. We do a lot with it. And the Bluetooth standard has evolved for a new one, which is kind of addresses a lot of the fundamental problems with traditional Bluetooth, and you're starting to see it in new iPhones, starting to come out in Samsung, called Bluetooth Smart. So that reduces the power, it addresses the issue of connectivity and pairing. So I think there's an evolution of it, and that was an example of something that was created a long time ago and standardized, and we've tried as humans, try to be ingenious about how we can leverage that wireless connectivity, and in parallel, kind of defining how that evolves too. So they kind of go hand in hand as a standardization over a period of time. I think that problem is very complex and different to somebody like Local trying to lock down on a very specific deliverable project.
Anyone else want to?
As a software guy, struggled with this a lot over the years. And when I joined Microsoft, we were going through that very difficult period of security issues, which caused the company to take a huge step back to go fix some of the underlying issues. And in solving the problem, it was a combination of factors. There was human factors involved. There was a lot of technology used to go hunt down issues. We developed some products that effectively looked at our code and identified highly likely issues. And so as we start applying, for example, natural language processing, and as we start to understand constructs, we'll use software to find software problems. Because it takes 10 minutes, I've been a software engineer, it takes 10 minutes to read somebody's code and know who wrote it. It's got their fingerprints all over it. So I think that's one step. Second thing is get away from writing software. It's possible to create mathematical models that create the connection between things, and then you're basing your factoids on a somewhat different method. So stop writing as much software, innovating in other areas. Make the tools much simpler, the building blocks much simpler, much more rugged, and they can be introspected. I don't think throwing on the brakes and stopping innovation would please an Apple iPhone user today when he wants to go find, or she wants to go find a bunch of apps. But there is a case for greater quality understanding in the world, and I don't think we teach enough in school on the quality end of the engineering. We tend to spend a lot of time on the theory, the software theory, the writing. The quality assurance piece could shift dramatically. So I think it's educational. I think it's an evolution in the software tools. I think it's stop using software and actually using mathematical modeling and some other abstracts. But it certainly isn't hang up the software writing toolkit quite yet, I don't think.
Yeah, I think it's certainly a big issue that needs to be addressed, but I'm much more worried about the hardware side. So because you physically got to visit that, whereas a software with machine-to-machine, you can actually provision it over the air, and it's doing it there. If you look what's going on in the car world at the moment, Ford had to send out, I've forgotten how many million of USB sticks, and then ask their customers to put that into a hole in the car to do a software update. I think they had about 10-15% uptake of that. That's just crazy in this world where everybody is used now to over-the-air updates and taking that through. But it's that hardware issue. So you get bugged there, then you've got the problem.
I think it's a fair point that we need to get this right depending on the severity of failure. So if your iPhone falls over when running a particular app, you reboot it, it may not be a problem. If your heart rate monitor falls over just at the point you need it to send an alert, that's not such a good thing. So horses for horses.
Which is, we use a Scrum technique at Living Planet. We're evolving very quickly. We're shipping a whole release every month. And as we get feedback, how you respond to those things is important. But there is a sense that distributed development, and I'm not talking open source now, that's a completely different bucket, but I think there are cultural differences in programming too. And I think that use of those natural skills, you deal with Russian engineers and they are brilliant mathematicians. There are various cultural differences, and I think diversity in the team that you build and the educational structures below it can help you catch a lot of things you otherwise wouldn't.
That's very important.
Next question. Yes, please, towards the back on my left.
Lewis Hartwell, MD of Be Informed UK Limited. I'm sure most of you have heard about what's called a target operating model. Whether it's the semantic city or whether it's transportation. Do you think that model-driven applications, I already have an answer on applications and software, we're not going to develop anymore. But do you not think that model-driven applications is one of the secrets to make this thing work?
Who would like to tackle that one?
Are you talking about the sort of model view control paradigm?
I think you might need to explain a bit more what you mean by a model-driven application.
Well, for example, we've got a situation, say, with troubled families here right now. There's quite a few applications that's got to run at the same time. There's a model that drives the top of that across that makes everything work. You don't have to really write new software around it. On the transportation side, we could do the same thing. It's how you want to operate the business, which actually changes the way you do business and the application to make that work. So that's a model-driven application based on business, not based on the software that runs it. So you got different silos working. You know, how do you make all those work together? And that's what I'm talking about, model-driven. How does the business work better?
Theo?
Yeah, no, I understand. For me, you're not normally starting in a greenfield site. So every city, every environment, whether that rural or urban, is different. And therefore, a model is going to be very complex to do that. And actually, I think a transportation model is something that is very achievable. And I mentioned the Transport Catapult, and one of their early projects, I understand, is a modelling of the transportation network. And I think, and that's definitely something that is of use. And we can then try in that virtual environment lots of other things. London Underground and TfL already have one. Network Rail have one as well. So combining all those together, we can do it. Actually, the issue that comes about is not ICT-led or mathematical or modelling-led. It's actually about people. And it's about different organisations having different goals and the complexities that they throw together. Now model that in a generic way. There's the challenge. So I think we can model the network, we can optimise the network, and my vision of, and I'm happy to chat about it afterwards, about autonomous vehicles and how that can revolutionise where we're going to. I think that is very easy to model ultimately. Very complex, don't get me wrong, but it's doable. We can take that elephant and chunk it down. But now throw in the dynamics of the human. That's the challenge.
So I'm going to take one more question. Before I do, I'm going to give the panel warning of what I'm going to ask them to do in summing up, which is to give me their thoughts on how the average person on the street would notice the change were we to have a smart infrastructure. What would it mean to them in their day-to-day lives? So we'll give you a few moments to ponder on that one. Do we have one last question? We do, over here on the far right-hand side. The microphone's just coming to you.
Thank you. Jenny Borg from the UK Department for Transport. A question as much for you, actually,
okay.
As everyone else, which is slightly a two-parter. I know your background is partly in Ofcom, and obviously there was lots of controversy in the UK about how 3G was rolled out. 4G is coming. How far off, and given your appreciation of some of the complexities and bureaucratic hurdles, how realistic and what time frame are we talking about for this level of communications? And secondly, a slightly technical question, which is if we are using white space, the UHF frequency, is that going to work with normal RFID readers or sensors, or is it going to require any kind of re-equipment? Thanks.
Okay. So very happy to tackle that. As you said, I spent quite some time with Ofcom, so I understand some of those issues. 4G and 4G rollout. As we heard this morning, in a way, 4G is not a step change. It's a sort of an evolution. It's a bit faster. We keep going a bit faster every few years, and we've gone a bit faster with 3G, and then sort of HSDPA packet data on 3G, and 4G sort of just keeps things evolving. So. In many respects, I think people may not even necessarily notice that much. It just keeps up the growth. When's it going to happen? Ofcom hope to have the auction sometime next year. That may or may not get delayed by legal challenges. We'll see. I suspect whatever happens, it will take 2 to 3 years for significant network rollout. But perhaps more importantly, you've got to get devices in the hands of people to use it. And that's going to take 2 to 3 years before we see widespread low enough cost chipsets that a large number of people take up 4G. And then the coverage, I think, remains to be seen. Ofcom have said that at least one license should have 98% geographical coverage. So if that succeeds and they manage to sell that license and that rollout occurs, then we should see quite widespread 4G coverage. But when a somewhat related concept was tried in the US, it was actually to do with public safety rather than 4G. There was actually a failure to sell that particular license. So we'll have to wait and see what transpires there. The other part of your question, white space and RFIDs, actually somewhat different. RFID frequencies are a little bit above the white space frequencies. And so RFID readers and tags should be completely unaffected by what happens in the white space. I don't think there's any particular overlap. I don't think anyone's thinking of moving RFID down into the white space or otherwise. So fingers crossed, that should all hang together without any particular issues there. I don't know if anyone on the panel wants to comment on 4G or similar. No. Okay, then it's over to my closing question to you all. So I ask you it because I sometimes get asked it myself, particularly by my wife. What are you doing, and how's it actually going to affect me? How will the person on the street notice that they have a smart infrastructure? And we'll start at the far end and work back. So, Dave, your thoughts on that?
One word, and that's experience. So it's experience in terms of how you shop, how you find things. It's experience in terms of how you educate yourself. It's experience in terms of your quality of life, healthcare, how you get access to services. And it's experience in your home, energy efficiency, autonomous driving. It's all about the experience that it affords the individual. I mean, technology exists for one reason only, and that's to make our lives better. It's to improve experiences that we as humans have. So ultimately, that's what it's about.
Yeah. Thank you. Deepak.
To a great extent, I'd agree with that. Just to put a location color on it, I think the ability to kind of be, leave my home, I know I'm going to go, the network knows I'm going to need a train that's going to arrive from a driverless demand-based system. That will be, always efficient in terms of its capacity. Networks that load, offload, depending on demand. The ability to interact with things around me, inside or outside, in a meaningful way. Healthcare, I think, is a big, big opportunity. I think, if you look at we can move on from a completely curative as opposed to preventative medicine care, interactive of devices as they go wrong in my home that could connect to my supplier via a network that will say, this is how you diagnose, this is what the problem is, those kind of things.
Steve?
Yeah, I would agree with that. So obviously, connectivity is taken for granted. We tend to get a little bit overly whipped up about connectivity. Connectivity is taken for granted. I think it depends who you are. So there are people in the world who don't even have clean water and energy today. For them, some of this will be profound because it's almost a 100-year shift for them. My great-grandmother grew up without water at home. Secondly, I think it's all about context. That the problem we have today is we have a multitude of devices, a multitude of applications, a multitude of data feeds. And really, I just want the piece of data and the app that's relevant to me in that time. So I don't want it from everything all the time. And so I think context will improve, not just because of physical locational services, which I think are critically important, but also what am I doing at that time in that space? So spatial awareness, locational awareness, and context. The last piece I would say is sort of intimacy. Great technology is stuff you typically, it's very subtle and you don't see it, it's not in your face. And I think the simplification where my mum will know how to go use a device because it's obvious. She's using a natural gesture or she's inferring something by her movement. I think that experience, the simplicity, the context, and ultimately all of it will be driven by first principles, which is what's my greatest need. If I've got chronic health, technology will start to aid in the management of that chronic health. If it's I've got to communicate to learn, it's going to have a profound impact on a lot of people that don't access those services. So I think a lot depends on where you are, what context you have, and ultimately what the priority is for an individual's life, which will become highly personalized, very fluid.
Thank you. Theo?
I think that, just to pick up on that last point about personalisation, I think it's going to be that.
Yeah.
No longer is it going to be one thing for everybody or one or two things for everybody. It's going to be narrowed down to you as an individual. So rather than search, you just get presented the piece of information that you're looking for or the product that you're looking for rather than a suite of 30 or 40 products. So to me, it's about that personalisation. And that's the main difference. But I do think that if we look from now to 30 years from now, actually, we won't notice that change. It's happening so fast and so pervasive that actually we'll look back in about 30 years' time and go, wow. And just as we do today, we look back and go, look at those mobile phones of the past and look what we've got on our hand now. Who knows what that future will be.
It sort of brings us full circle to something Dave said at the start, which is technology finally adapting to us. Yeah. Okay, well, before I let you go, I've got a couple of minutes of closing remarks. But first, I think we should say thank you very much to our panel for some great answers.